Dear students, I am Mahesh Javalkar of Maratha Mandal Polytechnic, and today I am posting my second video on the DCET questions for the subject EMI, Electronic Measurement and Instrumentations. Okay, so next we'll start with the first question, question number 21. The most probable value of a measured variable is the dash of the number of readings taken. Okay, now is the dash of the number of readings taken means it should be an average value, and the average value is called as arithmetic mean. Okay, so here the answer should be arithmetic mean. So the most probable value of a measured variable is the arithmetic mean of the number of readings taken. So option A will be the right answer. Option A, that is arithmetic mean. Then we'll go to the next question. Question number 22. Dash is the departure of a given reading from the arithmetic mean of the group of readings. Okay. Dash is the departure, means it is going away from the arithmetic, from the mean value. Okay. So dash is the departure from the mean value in the group of readings. So that should be deviation from the mean. Okay. So that should be deviation from the mean. So option D will be the right answer. Then we'll go to the next question. The dash is an indication of the precision of the instrument used in measurement. Okay, so dash is an indication of the precision. Precision means the number of readings you're taking, and when the number of readings are very close to each other always, then it is highly precise. There is not much error. Okay, that means you are speaking about something called as average deviation. Okay, so the average deviation is an indication of the precision of the instrument used in measurement. Okay, so here the option C will be the right answer, average deviation. Then we'll go to the next question. Highly precise instruments whose precision is more yield a dash average deviation between the readings. Okay, if the precision of an instrument is more, then deviation should be low. So average deviation should be low. Okay, if the deviation of the value from the desired value is less, then only it is highly precise. So highly precise instruments yields a low average deviation between readings. So option A should be the right answer over here, low. Okay, then we'll go to the next question. The basic PMMC moment is often called D'Arsonval moment and is used to measure. Okay, now we all have studied this PMMC, permanent magnet moving coil, which is also called as D'Arsonval moment, and it is going to measure only DC. It is going to measure only DC. It is not used for AC. Okay, so here the answer should be A, DC only. The basic PMMC moment, which is often called as D'Arsonval moment, is used to measure DC only. Okay, then we'll go to the next question. The unit of sensitivity is what? Okay, so the options here are A is volt, B is ohm, volt upon ohm, and ohm upon volt. Okay, so here we can write that sensitivity can be defined as, okay, 1 upon full scale deflection of the current. 1 upon full scale deflection of the current. So if you take current in terms of voltage and resistance, then it will be 1 upon V upon R. Okay, this is nothing but R upon V, which will resemble to ohms per volts. Okay, so ohm per volt will be the correct unit for sensitivity. So sensitivity measured in ohms per volt. So option D will be the right answer. So next we'll go to the question number 27. The range of a voltmeter can be extended by using, okay, series resistance or shunt resistance or series shunt resistance or none of this. Okay, so we have seen that whenever we use a series resistance along with a D'Arsonval moment, okay, D'Arsonval moment, So then it is giving a concept of voltmeter. Okay, so it is a series resistance which will extend the range of an voltmeter. Clear? Then we'll go to the next question. Question number 28. A series resistance along with the PMMC meter is used to form what? So again, the same type of question. Whenever we have a series resistance along with a d orthogonal moment, okay, d orthogonal moment. This is your PMMC or d orthogonal moment, okay, or d orthogonal moment. So whenever we have a series resistance RS, so it is a concept of a voltmeter. So this is a concept of DC voltmeter. Okay, so it should be a voltmeter. A series a resistance along with a PMMC meter is to form a voltmeter. Okay, next we'll go to question number 29. A shunt resistance is used along with PMMC meter to form what? Okay, so again the same type of basic question. If you are having a shunt resistance, okay, if you are having a shunt resistance and if you are having a d orthogonal moment here, so, okay, so the resistance is across the d orthogonal moment. This is your PMMC meter or d orthogonal moment. Anything you can call it as d orthogonal moment. Okay, and this is your shunt resistance. So okay, so this concepts gives a concept of DC ammeter. This concept gives a concept of DC ammeter. Whenever a resistance is across the PMMC, it is parallel to PMMC, it is DC ammeter. If it is series to PMMC, it is voltmeter. Okay, so here the option should be option C because it is a shunt resistance. So ammeter. Okay. Then we'll go to the next question, question number 30. The force which is responsible for the movement of a pointer in a meter. The force which is responsible for a movement of a pointer. So this is a scale, you can say. This is your scale, calibrated scale. And if you are having a pointer here, and if the pointer moves like this because of the sensing of current or anything, any other parameter, it is moving because of something called as deflecting torque. This is the answer, deflecting torque. Deflecting torque is one which is going to move the pointer in the meter. Okay, so answer should be A, deflecting torque. Then we'll go to the next question, question number 31. One of the following instruments is suitable for measuring AC only. Measuring AC only. So if you see here, PMMC is used for measuring DC. PMMI, that is permanent magnet moving coil, is used for AC and DC both. AC and DC both. Electrodynamometer is again AC and DC both. Okay, and DC both. Whereas the induction type, which will have a magnet and it will give you a flux and it works only for AC, not for DC. Okay, so here the answer should be answer D. Answer D will be the right answer. That is, induction type of instruments are suitable for measuring AC only. So D answer is the right answer. Induction type instruments. Then we'll go to the next question. All analog meters used for measuring current I, voltage V, and resistance ohms are what type of meters? So basically we use current. Basically we use current, a proportional current, and that proportional current is then converted to a voltage across a resistance or to a resistance if you take voltage upon current or the current itself. Okay, so basically the sensing parameter will be a current and a proportional current will be converted into a proportional voltage or resistance or the current itself. So it is current meters. All analog meters used for measuring I, V and ohms are current meters. Okay, so here the option will be option A, current meters. Then we'll go to the next question. The time base of a CRO is developed by what? Okay, so the time base of CRO is developed by something called as sawtooth waveform. This is sawtooth. It is like charging and discharging of a capacitor. Okay, which will give you the horizontal timing. So the horizontal section uses this. So the time base of a CRO is developed by sawtooth waveform. So answer should be B, sawtooth waveform. Okay. Then we'll go to the next question. The time-based generation in a CRO will be present in, as I've told you earlier also, it will be present in horizontal section because it is going to control the x-axis of a CRO. Okay, so x-axis of a CRO, this part is controlled by the horizontal section. The horizontal movement, not the vertical movement. Y-axis is not controlled. X-axis is controlled by a horizontal section. So time-based generation in a CRO will be present in horizontal section. Option A will be the right answer here. Then we'll go to the next question. Time-based generator uses, okay, obviously as I've told you, it was a sawtooth waveform and it uses a concept of capacitor where charging and discharging of capacitor. Okay, so charging and discharging of capacitor will give you something like this, like your sawtooth wave, charging, discharging, charging, discharging, charging, discharging, charging, discharging. Okay, and this is what is used in your horizontal section of CRO. Okay, then the answer should be C, charging and discharging property of a capacitor. Then we'll go to the next question. The CRO uses dash method of focusing. So the options are electronic, electromagnetic, electrostatic, and electromechanical. Obviously, it is electrostatic. Okay, whenever the electron beam moves, okay, whenever the electron beam moves through the this thing tube of the CRT, okay, so it is accelerated by potentials, okay, positive potentials on both sides, and those potentials, okay, whenever it is going to accelerate or whenever it is going to deaccelerate with a negative potential, these potentials make a electrostatic lens, okay, and those lens act just like the lenses of the optical. So there you can see the refraction of the beam can bend. Okay, so movement of the beam can be done whether it is horizontal or vertical. So movement of the beam can be done with that. So it is not optical lenses, it is not electromagnetic lenses, it is called as electrostatic lenses. Okay, so this type of focusing is electrostatic focusing. So option C will be the right answer here. The CRO uses method of electrostatic focusing. Okay, electrostatic method of focusing. Then we'll go to the next question, question number 37. In CRT, the highest positive potential is given to, okay, so the highest positive potential is given to the post deflection accelerating anode. After deflection, the accelerating anode towards the tube, okay, so that is the answer over here, post deflection accelerating anode. Okay, after a deflection, what you're accelerating you want till the screen, okay, so that post deflection accelerating anode is there, so that will be given the most highest positive potential so that it can attract the electrons. Okay, then we can go to the next question, question number 38. Voltage sweep generators are used in, okay, so CRO is having a screen and an electron beam in which the electron beam will move left and right. It can show a light on the other side. TV also is having the same type of concept. So voltage sweep is there in both CRO and also in TV. So option both A and B will be the right answer over here. Voltage sweep generators are used in both CRO and TV. Then we'll go to the next question. Lissajous figures are used for measuring what? Option A is current, option B is frequency, option C is voltage, option D is resistance. Okay, so Lissajous figures are used for measuring frequency. Okay, so the option B will be the right answer over here. Lissajous figures are used for measuring frequency. Clear? Then we will go to the next question. Volts per division setting on the CRO changes what? Volts per division setting is going to reflect the waveform on the vertical axis. Okay, so vertical section. So volts per division, okay, it's for vertical section, and time per division is for horizontal section. Clear? So gain of the vertical section is one which is going to change volts per division setting. Okay, so volts per division setting on the CRO changes gain of the vertical section. So option A will be the right answer over here. gain of the vertical section. Okay. So students, these were another 20 questions on EMI subject which I have taken. So this type of questions can come in your DCET. So see that your basic fundamentals are clear and or try to derive the logic of every question on your own. Okay. Thank you very much.